Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 2 of the lesson on differentiating sine and cos, and in this video I'm just going to be going through two important examples of differentiation that students tend to get wrong a lot of the time. So the first one I have is find dy dx given that y equals sine squared x. And the most common mistake that students make, well, I won't tell you, have a go. Pause the video, see what you think. Most common mistake that students make, hopefully this isn't you, cos squared x. Because they think, oh, sine differentiates to cos, sine squared to cos squared. Great. Alas, no. What we need to think about with this is what sine squared x means, or how else we could write sine squared x, and that will give us a nudge as to how we differentiate it. Well, sine squared x means sine of x squared. So I'm going to write it as sine of x squared in a bracket. And looking at it like that, you might have a bit more of an idea of how we differentiate it, because I have a function in a bracket with a power. It means I'm cracking out the chain rule. So, chain rule, dy by dx equals power down, bracket stays the same, reduce the power by 1, and then crucially, multiply by the differentiated bracket. And we know from the previous video that sine differentiates to cos, so therefore our expression for dy dx is 2 sine x cos x. Absolutely crucial that you write it like this first, because that will prompt you to use the chain rule and avoid the error of thinking it's cos squared. Second example here then, show that d by dx of 2 cos squared 3x equals mu sine 3x cos 3x, where mu is a constant to be determined. That means that this is just going to be a number. So mu represents a number. Now d by dx means the derivative of what follows. So what this is actually asking you to do is to differentiate 2 cos squared 3x. But sometimes students get confused by that. It's perfectly acceptable to write y equals and then the thing that your function that you're trying to differentiate. Importantly though, cos squared 3x, it's only the cos 3x that's squared, not the 2. So when you write this, it would be 2 bracket cos 3x squared, like so. So you've just seen that one with the chain rule. Think about how to differentiate that one with the chain rule. Pause the video while you do it and come back in a moment or two. There's a classic mistake here that students make all the time. Hopefully this wasn't you. Chain rule. So dy by dx equals power down. So multiply by the 2, cos 3x, subtract 1 from the power, and multiply by the differentiated bracket. Now cos differentiates to negative sine. So it's negative sine 3x. Classic mistake, here it is. Students forget that because it's cos 3x, you have to multiply by 3. That is the key bit that floors people every single time. It's almost like a chain rule within a chain rule. People forget that because you've done 2 times the 2 at the front and subtracted 1 from the power, you think, oh yeah, I'm done, but cos 3x will differentiate to negative sine 3x times 3. It's really, really important. Most common mistakes, students forget that 3. So let's just have a think about what that's left us with. So 2 times 2 times 3, and it's going to be negative. So overall, I'm going to have negative 12. And then traditionally, you tend to write sine before cos when you have a combination of both in an expression, in a term. So negative 12 sine 3x cos 3x. Is the result of differentiating. So, referring back to the original question, we were looking for a number of sine 3x cos 3x, so we can be happy we've got it in the required form, and the number, mu, in this case, is negative 12. If you got negative 4, you know what happened. You missed off that 3. Don't do it. I'll see you in the next video.